So continuing on with our talk about quadratic functions and parabolas. In class the other day and in the previous notes, we talked about a function in the form of y equals ax squared. Okay? And we talked about a little bit about how the value of a is going to affect the graph of the parent function of y equals x squared. Remember that parent function sat at the origin, and it was the most basic version of these quadratic functions. So what we're looking at is how a is going to affect the graph of y equals x squared. So what we're looking at is when the absolute value of a is greater than 1, meaning we're looking at some sort of an integer being in front of that x squared, having a coefficient on that x squared term. We noticed in class the other day when we looked at a few of the graphs that it caused the graph to get narrower because the values, the y values or the function values, were growing at a more rapid pace. Whereas if the absolute value of a is less than 1, some sort of a fraction between 0 and 1, then that caused those function values to increase at a slower rate, and therefore our parent function, our graph, got a little bit wider. Okay? So if we look at the three functions given in the problem above, it wants us to put them in order as far as which ones would be the widest and which ones would be the narrowest. Okay, so what is the order from widest to narrowest of the graphs? Well, we know the widest functions are going to have some sort of a fraction between 0 and 1 as their coefficient. And the smaller the fraction, the wider the graph will be. Okay? So if we look at these, this function in the middle here, that would be the widest. So our widest function would be the f of x equals 1/4 x squared. That's the only one that has a fraction between 0 and 1. Okay? So the next widest fraction, or the next widest function, excuse me, if I look at the values, I've got -4 in the first function and I've got +1 in the third function. But remember, we're looking at the absolute values when we're considering wider and narrower. So the negative in front of the 4 really doesn't have any bearing on how wide or how narrow it is. It's just the 4 and the 1. Okay? So the next one in the list, as far as going from wide to narrow, would be the parent function of f of x equals x squared, which means that the narrowest of these functions is going to be the -4x squared, because that's the one where the function values are going to be changing the fastest. Okay, so that graph gets narrow, it gets a little bit steeper if you want to think of it in those terms. Okay. And here you can see what those graphs look like. Okay. Here is our 1/4 x squared. We said that was number 1 as far as being the widest graph. Here is our parent function, okay, over here of f of x equals x squared. And then finally, our narrowest of the functions had the -4x. Okay? Now notice what the negative has done to our graph. That's the only function that has a negative, and it's the only function that opens down, okay, to where we have a maximum for our vertex, where both of these functions, our vertex is going to be a minimum value because the graph is opening up. Okay? So take a minute and look at these three functions and see if you can put them in order from widest to narrowest. 1, 2, and 3. Okay, going from wide down to narrow. Okay. Well, the widest function would be the one with the smallest number between 0 and 1. Okay, so we're looking down here at that -1/3. So our widest function is going to be the f of x equals -1/3 x squared. The next widest function would be the f of x equals -x squared. The absolute value of its coefficient is a 1, and the narrowest of the group is going to be the f of x equals 3x squared. So the larger the absolute value, the narrower the graph is going to be. Okay. So for the next thing we're looking at, we talked a little bit the other day about the axis of symmetry, And when we had our parent function, we knew that the y-axis was that axis of symmetry. It was the kind of the dead center of the graph. Okay. So that y-axis is still going to be the axis of symmetry, even if we have a function in this form of y equals ax squared plus c, where we have some constant being added to my x squared term. Okay. So what is that constant going to do? So how is the graph of y equals 2x squared plus 3 different from the graph of y equals 2x squared? Well, what this constant does, this plus c, is it causes a vertical shift. Okay? Meaning it takes the entire graph and it shifts it up or down depending on whether it's a plus or a minus. Okay? So this constant of positive 3, since they both have a 2x squared, they're going to have the same identical shape. But the difference is that positive 3 is going to shift the entire graph up 3 units. Okay? If it were a minus 3, the entire graph would slide down 3 units. So adding that constant, whether it's adding or subtracting it, is going to shift that graph or translate that graph up or down. Okay? So let's look at these two graphs. The graph of y equals x squared and the graph of x squared minus 3. Okay? So let's look at y equals x squared. We should know that one. That's our parent function. And if we're going to graph y equals x squared, if we think about our table of values, we know that 0, 0 is the origin, so that's where our vertex is. If I put in 1 for x, I'm going to get 1 for y. If I put in 2, 2 squared would give me 4. So I'd have 1, 1, I'd have 2, 4, okay, and we graphed this the other day as well. And we can see that graph is going to kind of take this shape. And using our symmetry, I'd have a point over here at negative 1, 1, and at negative 2, 4. And that would kind of give me the other side of the graph. Okay. And if we go and we look at this x squared minus 3, and we start choosing, if we were to choose the same 3 values, if I put in 0 for x, now I'm going to get a negative 3 for y. Okay? And if I put in 1, I'm going to get 1 minus 3, which is negative 2. And if I put in positive 2 squared is 4, minus 3 is 1. So I have a 1, negative 2, and I have a 2 and positive 1. So here is the right side of that graph, and if we go and use our idea of symmetry, we've got negative 1, negative 2, and we've got negative 2, positive 1. So we've got the other side of the graph. Okay? And now look at what happened to our graph. Look at what the difference is in these two graphs. All of the points from the vertex here in the middle to this point over here, this point, all of these points have simply shifted down 3 units. Okay. And that's what that minus 3 is doing out there. That minus 3 on our graph has taken that entire graph and shifted it down 3 units. So our new graph is simply the parent function of y equals x squared, and it's been translated or it's been shifted down 3 units in the coordinate plane. Hasn't changed shape, just changed locations. Okay. So let's see if we can graph this function. Y equals 1/2 x squared. And let's think about where would that vertex be for that graph. Okay. Well, remember the parent function of y equals x squared. Okay. Where was its vertex? The vertex of y equals x squared was at 0, 0. And we talked about that constant on the end causes a vertical shift. So that plus 2 is going to take every point and shift it up 2 units, which means our new vertex is going to end up at 0, 2. Okay, up here at 0, 2. So now let's pick some other values. We know we have 0, 2. Now, we talked about this. We've got a fraction as our coefficient. So what we want to do, remember, is we want to pick values for x that are multiples of 2 so that I won't have fractions for my y's. So when I put in x is 2, 2 squared is 4, half of that is 2, plus 2 gives me the point 24. Okay? And if I've got the point 24, then the symmetry is also going to give me the point negative 24. If I put in positive 4, 4 squared is 16, half of 16 is 8, plus 2 gives me a point at 410, all the way up here at the top. And if I've got the point at 410, the symmetry tells me I'd have the point at negative 410 as well, because the y-axis is my axis of symmetry. So now I can sketch in my parabola. Okay? So again, the focus here is that this constant is causing the entire graph to shift up 2 units. So if I remember that the parent function has a vertex at 0, 0, and I see a squared plus a constant, I know that that vertex is simply shifting up 2 units to the point 0, 2. Okay? So we'll do some more of this graphing and work on some practice problems in class tomorrow. See you then.